Hey everyone, ready for a deep dive into the world of microsystem engineering?
Sounds exciting.
It is. We're talking about those tiny components, like
Yeah.
smaller than a grain of sand.
Oh, wow. Yeah. Sensors and actuators and all that.
Exactly. They're in everything these days, from our phones to medical devices, and they're only becoming more important.
Absolutely.
We're going to be focusing on how to nail a microsystem engineer interview using some prep materials from RoleCatcher.
Great idea.
This seems like a really cool platform, way more than just your average job board.
It looks really comprehensive. Yeah.
So you've been in the microsystems engineering field for a while now.
I have, yes.
What really gets you excited about this kind of work?
I think for me, it's the impact. It's amazing to think that these tiny things we're designing are actually influencing massive industries.
Yeah, that's a great point.
Like, think about healthcare or aerospace, even. The things we're working on can revolutionize these fields.
Absolutely. And the listeners sent over some really great resources from RoleCatcher.
Oh, yeah.
Yeah, it looks like they have thousands of career guides, interview guides, and they even have, get this, an AI coach that helps you tailor your answers.
Whoa. That sounds pretty high tech.
Yeah, so I think that could be really useful for our listener.
Definitely.
The AI analyzes your responses and gives you feedback based on the job you're targeting.
So it's like having someone on the inside telling you what the hiring managers are looking for.
Exactly. Pretty cool, right?
Definitely cool.
Okay, let's jump right into those interview questions. The first one asks about experience with designing and testing complex microsystems. Seems pretty straightforward, but what do you think they're really looking for here?
Well, on the surface, it seems simple, but they really want to see some depth.
More than just listing projects on your resume.
Exactly. They want to see that you can not only design these intricate systems, but also test them rigorously and troubleshoot any problems.
Right, because things are bound to go wrong at some point, especially with something so complex.
Exactly. So when you answer this question, I would suggest focusing on specific projects where you faced some serious challenges.
Talk about the roadblocks you encountered.
Yes, and how you overcame them. Did you use any innovative techniques for testing or design?
And using the STAR method would probably be a good idea here.
Oh, definitely. The STAR method is always a winner. Situation, task, action, result. It really helps structure your experience in a clear and compelling way.
So the interviewer can easily follow your train of thought. And what about follow-up questions, should our listener have some ready?
Oh, absolutely. Asking thoughtful follow-up questions can really make you stand out. It shows you're engaged and genuinely interested in the work they're doing.
What kind of question would you suggest?
Maybe something like, what are some of the most challenging microsystem designs your team is currently working on?
Ooh, I like that. It shows you've done your homework and that you're eager to contribute your expertise.
Exactly. Okay, let's move on to the next question. How do you ensure the reliability and durability of microsystems? Now, this one gets to the heart of the matter.
Yeah, because with these tiny components, reliability is absolutely crucial.
Especially when you think about applications like medical implants or aerospace components.
There's no room for error?
Right. So you need to demonstrate a deep understanding of industry standards and testing procedures.
Okay, so mentioning specific tests would probably be a good idea here.
Absolutely. Talk about things like stress tests, temperature cycling, vibration testing. Show them you understand the rigorous demands of the field.
Right, because these microsystems need to function flawlessly under a wide range of conditions.
Exactly. And even mentioning specific industry standards like MIL STD 883, for example, can really set you apart.
It shows you're committed to quality and reliability. And would it be good to have a follow-up question for this one, too?
Oh, for sure. Maybe something along the lines of, what specific reliability standards or certifications are most important for this role?
That's a good one. It shows you're already thinking about how to meet their exact requirements.
Exactly. All right, let's move on to question number 3. How do you stay up to date with the latest microsystem technologies and trends?
This is where you get to showcase your passion for the field.
It's not just about geeking out, though.
True.
It's about showing them that you're committed to lifelong learning, that you're always eager to expand your knowledge and stay ahead of the curve.
Because this is a field that's constantly evolving.
Right. So mention specific publications you follow, conferences you've attended, online communities where you engage with other engineers.
What about a follow-up question for this one?
Maybe something like, does your company encourage employees to attend industry events or pursue further education?
Ooh, that's clever. It suggests that you're not just looking for a job, you're looking for a place to grow.
Exactly. A company that invests in its employees' development. Okay, question number 4. Can you walk me through your process for troubleshooting microsystems?
Ooh, this is a good one. Troubleshooting is a critical skill in any engineering field, but I imagine it's especially important in microsystems.
You're absolutely right. These systems are so complex and miniaturized that troubleshooting can be like solving a microscopic puzzle.
Like being a detective on a tiny scale.
Exactly. So when you answer this question, be methodical, walk them through your step-by-step approach to identifying the root cause of a problem.
So, like, do you start with a visual inspection? Do you use any specialized diagnostic tools?
Yes, exactly. Describe the techniques you use to isolate the issue.
Okay, how about a follow-up question for this one?
Maybe something like, what kind of support systems or resources are available to engineers for troubleshooting difficult problems?
That's a great question. It shows you're thinking about the collaborative environment.
Right. It shows you understand that even the best engineers sometimes need help. All right, let's move on to question number 5. This one's about balancing cost and performance when designing microsystems.
That's always a challenge, isn't it? You want the best performance possible, but you also have to stay within budget.
It's a classic engineering dilemma. So here's where you showcase your understanding of trade-offs. How do you prioritize features based on project requirements?
And how do you factor in budget limitations?
Exactly. You might want to mention your experience with simulation software.
Oh, yeah, that's a good point. Using these advanced tools shows that you're committed to finding the optimal balance between cost and performance.
Exactly. All right, question number 6. Describe your experience with MEMS sensors.
Now, before we go any further, maybe we should quickly clarify what MEMS stands for, just in case our listeners aren't familiar with the term.
Sure, MEMS stands for micro electromechanical systems.
And these are basically tiny devices that combine mechanical elements like springs and gears with electrical components.
Right, and they're incredibly versatile and sensitive. They're used in all sorts of applications. So this question is really your chance to dive into the specifics of your expertise.
So if you've worked with accelerometers, gyroscopes, any specific type of MEMS sensor, this is where you talk about it.
Exactly. Highlight your experience and knowledge in this area. And don't forget about a follow-up question.
What would be a good one here?
Maybe something like, what types of MEMS sensors are particularly important for your company's products or research?
Oh, that's a good one. It
Yeah.
shows you've done your research and you're interested in their specific needs.
Exactly. All right, question number 7 gets into regulatory requirements. How do you ensure that microsystems meet regulatory requirements?
This is a big one, especially in a field with such wide-ranging applications.
Absolutely. Safety and compliance are paramount. So talk about your experience working with regulatory bodies like the FDA or CE. Have you implemented any specific quality control measures?
Right. What kind of testing protocols have you followed?
Exactly. And you could even ask a follow-up question like, are there any specific regulatory challenges that your company is currently facing in the microsystems field?
Oh, that's a smart one. It shows you're aware of the broader industry landscape and the evolving regulatory environment.
Exactly. Now, before we move on to the final question, I want to touch on something we mentioned earlier, RoleCatcher's AI feedback.
Oh, yes. I think this could be incredibly helpful for our listener.
Yeah.
It's amazing how RoleCatcher can analyze your answers and suggest ways to improve them.
It's like having a personal coach guiding you towards the language and keywords that resonate with hiring managers.
Exactly. Okay, let's tackle the last question. Can you give an example of a time when you had to work with a cross-functional team to design a microsystem?
Collaboration is essential in this field, so this question is really getting at your teamwork skills.
Right, because you're often working with people from different disciplines.
Exactly. So choose an example that showcases your communication skills and your ability to collaborate effectively. Maybe a project where you worked with mechanical engineers, electrical engineers, material scientists.
Yeah, that's a great example. And what about a follow-up question?
How about, how does your company foster communication and collaboration between different teams?
Oh, I like that. It shows you're interested in their work culture and how they promote a positive and productive environment.
Exactly. So we've covered a lot of ground here, and I think our listener is well on their way to acing that interview. But before we wrap up this deep dive, I want to touch on some broader insights from RoleCatcher's Career Guide.
Sounds good to me. Okay, so we just went through all those interview questions.
Yeah.
And I'm feeling pretty confident that our listener is going to rock that interview.
Yeah, I think so too.
But before we wrap up, I'm really intrigued by something the RoleCatcher Career Guide mentioned.
Oh, yeah. What's that?
It's these adjacent career paths.
Oh, interesting.
It's like either if microsystem engineering is your main goal,
Right.
knowing what else is out there can give you an advantage, don't you think?
I totally agree. Exploring those adjacent paths can open up all sorts of possibilities.
Yeah.
Like you're looking at your skills and interests through a whole new
Yeah,
lens.
exactly.
You might discover something you hadn't even considered before.
Okay, so the guide lists a bunch of adjacent careers, but the one that really caught my eye is microelectronics engineering.
Oh, yeah. Good one.
They seem pretty intertwined with microsystems.
They are, definitely.
So what's the connection there?
Well, microelectronics engineers are all about integrated circuits.
Okay.
Those tiny chips that power everything.
Smartphones, computers, all that.
Exactly. They're pushing the limits of miniaturization, and their work is really fundamental to the advancements we see in microsystems.
So if you're passionate about designing and building those really advanced, tiny devices,
Right.
a background in microelectronics could be a big plus.
It would be huge. Imagine being able to not only design the microsystem itself,
Yeah.
but also understanding the ins and outs of the circuits that make it work.
That's next level.
It really is. That kind of expertise would
Well-
make you incredibly valuable to any team.
And RoleCatcher actually has this cool feature called transferable skills.
I saw that, yeah.
It analyzes your skills and experience,
Right.
and then it suggests careers that might be a good fit.
That's so helpful.
It's like having a personalized career counselor in your pocket.
I love that analogy. It's true, though. You might find that your skills in microsystem design
Yeah.
actually translate really well to microelectronics or even some other related field.
That's awesome. Now, speaking of skills, the RoleCatcher Career Guide also dives into the key knowledge and skills needed for microsystem engineering.
Yeah, it's like a roadmap.
It is. It breaks down everything you need to know to be successful in this field.
Let's talk about those key areas. First off, you absolutely need a solid foundation in engineering principles.
Okay, the basics.
Right. Mechanics, thermodynamics, material science.
Of course, electrical engineering.
Can't forget that one. So really understanding how things work at a fundamental level.
Gotcha.
Then comes expertise in microfabrication techniques. This is where the magic really happens.
This is where those designs become real devices.
Exactly. It's all about transforming those intricate designs into actual functioning devices.
I bet that involves some pretty specialized processes, right?
Oh, yeah, for sure. Things like photolithography, etching, deposition, they're all used to create those incredibly tiny features on silicon wafers.
It sounds very high-tech.
It is. And then there's the knowledge of MEMS design and simulation software.
Okay, this is where the computers come in.
Exactly. These tools allow engineers to design, model, and test their creations virtually before they're even fabricated.
So it's like building a virtual prototype first.
It is, exactly. It helps optimize a design, ensure everything's going to work, and it avoids those costly errors during fabrication.
That makes a lot of sense. And I imagine that being able to characterize and test these microsystems is also super important.
Absolutely. Once you've built your microsystem,
Right.
you have to put it through its paces. So you need a variety of tests to assess how well it performs, its reliability, how durable it is,
So like measuring its sensitivity, accuracy, response time.
all of that. Yep. And also how well it holds up under different environmental conditions.
So it's not just about making it work, it's about making sure it works perfectly in the real world.
Exactly. Those tests are critical for ensuring that the microsystem meets all the requirements.
Wow. There's a lot more to it than I initially thought.
It's quite a process, for sure, but it's so fascinating to see how these tiny devices are created.
It really is. And the RoleCatcher Career Guide also emphasizes the importance of staying up to date,
Oh, absolutely. This field is always evolving.
Yeah.
New technologies are popping up all the time.
So how do you recommend staying on top of all that?
Well, the guide actually suggests some specific conferences to attend, publications to follow,
Right.
even some online communities to join.
That's a good starting point.
It is. It's a great way to stay plugged into the latest trends.
And to connect with other experts in the field.
Definitely. And it also shows potential employers that you're passionate about this work, that you're engaged.
And that you're committed to staying at the forefront of the field.
Exactly. Now let's shift gears a bit and talk about something else the RoleCatcher Career Guide mentions.
Okay.
Understanding the different career stages within microsystem engineering.
Oh, interesting. It's like mapping out your potential career path.
It is. It gives you a sense of where your journey in this field could lead.
So
Perfect.
it's like looking into a crystal ball and seeing where you could be in 5, 10, even 20 years.
Exactly. It helps you visualize those long-term goals. So the guide lays out this progression,
Oh,
starting with the entry-level microsystem engineer.
makes sense.
This is where you're really getting your hands dirty,
Learning the ropes,
Yeah, assisting with research and development, helping out with design and testing.
soaking up all that knowledge from the senior engineers,
Exactly. It's all about proving yourself, showing that you've got a solid grasp of those engineering principles, that you're not afraid of hard work.
and that you're eager to learn.
That's key. They even mention the value of certifications, like MEMS fundamentals in design.
Oh, interesting.
It shows that you're serious about building your expertise.
Right, so even at the entry level, certifications can give you a bit of an edge.
Definitely. Okay, so moving up the ladder, we have the junior microsystem engineer.
Okay, what's different here?
Well, now you're taking on more responsibility.
Okay.
You're actually designing and developing microsystems for specific applications, running simulations, working more closely with teams.
So it was less about assisting and more about leading.
Exactly. And the example profile for this level really stresses the importance of expertise in those areas: design, simulation, and collaboration.
And they mentioned certifications again here.
They do, yeah. Things like MEMS design and analysis.
So you're deepening your specialized knowledge.
Precisely. Okay, so next up we have the senior microsystem engineer role.
This is where you're the expert, right?
Pretty much, yeah. You're leading those complex projects, mentoring the junior engineers, driving innovation within the team.
You're the go-to person for all things microsystems.
You got it. The example profile for the stage highlights a few key things: extensive experience, leadership skills, a proven track record of delivering those high-performance products.
Makes sense. You've got to have the experience to back it up at this level.
Absolutely. They often mention having an advanced degree as well.
Oh, interesting. So continued education is still important, even when you're at the top of your game.
It is, definitely. It shows that you're committed to staying ahead of the curve.
Okay, so now for the peak of the mountain, the pinnacle, as the guide calls it.
The big boss.
That's the principal microsystem engineer.
What does this role look like?
This is where you're shaping the strategic direction of the whole field.
Wow, that's impressive.
You're the subject matter expert. You're collaborating with the executive leadership.
You're not just building microsystems anymore?
No, you're influencing the future of the entire industry. That's pretty amazing. What kind of experience do you need to get there?
Well, the example profile mentions leading strategic direction, being a recognized expert in the field.
And often having a PhD.
Yeah, it's the culmination of all those years of hard work and dedication, a real passion for this field.
It's inspiring to see that there's so much room for growth in this career.
Isn't it? Whether you want to be a technical specialist, a project leader, or a visionary leader, there's a path for you.
So knowing all this about the different career stages, how can our listener use that to their advantage in the interview?
That's a great question. It's all about framing your answers to align with the specific role you're applying for.
So if it's an entry-level position, you'd emphasize your eagerness to learn, your relevant coursework, those foundational certifications.
Exactly. And if it's a more senior role, you'd highlight your leadership experience, those times you've tackled those really complex challenges.
Okay, that makes sense. It's all about tailoring your message to the audience.
You got it. And don't forget about RoleCatcher's Career Compass feature.
Oh, yeah, we talked about that earlier.
It's a great tool for exploring those different career stages in more detail.
Seeing what skills are needed at each level, getting a clearer picture of where you fit in.
Exactly. Okay, so we've covered a lot of ground in this deep dive.
We have.
We've explored the world of microsystem engineering, from those tiny components to the career paths that await.
We've talked about those crucial interview questions.
And how RoleCatcher can be an invaluable resource in your job search.
So to our listener, I just want to say, go into that interview with confidence.
We've got this.
You've got the knowledge, the preparation, and the passion to succeed in this incredible field.
And remember, RoleCatcher is in your corner.
Their resources, especially that AI feedback, can really give you an edge.
Now, here's a final thought as you embark on your journey in microsystem engineering.
Okay, I'm listening.
The world of microsystems is constantly evolving. New technologies are always emerging.
Yeah.
So don't be afraid to think big, to push those boundaries, to contribute your unique skills to this amazing field.
Who knows? Your work could change the world in ways we can't even imagine yet.
Exactly. Now go out there and rock that interview.
We're rooting for you.